Hi students, I am Naresh. Welcome to my channel Jet I Teach. Exercise 1.1 question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Okay, so we need to concentrate on odd integers in this question. You can use Euclid's algorithm to solve this problem. Euclid's algorithm. Okay, what's the Euclid's algorithm? A equal to bq plus r 0 less than or equal to r less than b. So what is A here, A, B, or here? Here A is any positive integer or is remainder. B is 6 integer. Okay, substitute 6 in this equation. First of all, why you need to take B as 6? If you look at the question, you will come to know 0 less than or B equal to 6. So from this, what's the value of R? 0, 1, 2, 3, 4, 5. These are the values of R. Okay, so then what's the value of therefore A equal to BQ? BQ means 6Q plus R. Okay, 6Q plus R. For all values of R, we need to write values of A. 6Q plus 0, 6Q plus 1, 6Q plus 2, 6Q plus 3, 6Q plus 4, 6Q plus 5. Okay, 6Q I have substituted 6 in place of B. I have substituted R for all values of R. If you look at 6Q plus 2, 6Q plus 4, what is your observation? Six Q plus 2, 6Q plus 4 are divisible by 2. So they are even integer. So we need to concentrate on odd integers. Okay, so write odd integers. 6Q plus 1, 6Q plus 3, 6Q plus 5. Okay, so I have ignored all even integers. I have taken other terms. Okay, these are the other terms. Okay, after elimination of all even integers, I took only other possible numbers. Okay, we need to prove these numbers are odd integers. How you need to prove as odd integers? You need to write as a 2k plus 1 form. So I'm taking 2 as a common factor, 3q plus 1. Here 2 as a common factor, 3q plus 1 plus 1. Why I have taken? If you expand it, 2 3s are 6, 6q, 2 1s are 2 plus 1, 2 plus 1, 3. Similarly this one, plus 2 plus 1. Okay, 2 3s are 6, 2 3s are 6, 6q plus 2 2s are 4 plus 1, 5. Okay, now 2k1 plus 1, 2k2 plus 1, 2k3 plus 1. Where k1, k2, k3 and k are some integers. Okay, just I wrote it clearly 6q plus 1, 6q plus 1, 6q plus 3, 6q plus 3 and 6q plus 5, 6q plus 5 are of the form 2k plus 1. If you look at 2k plus 1 form, where k1, k2, k3 and k are some integers. Therefore 6q plus 1, 6q plus 3, 6q plus 5 are not exactly divisible by 2. So they are odd numbers. Okay, all these terms are in the form of 2k plus 1. 2k plus 1 means they are not exactly divisible by 2. So they are odd integer. Therefore any odd integers can be expressed in the form 6q plus 1, 6q plus 3, 6q plus 5. It's a final. Okay, it's a final declaration. Okay, can have a look at this. I have used Euclid's algorithm, and then I have taken b as 6. I wrote all values of r. Based on that, I wrote value of A for each and every value of R. In the question they are given as odd integers, so I have eliminated even integers. I have taken other integers. Other integers I wrote like a 2k plus 1 form. They are in 2k plus 1 form. Therefore, these terms are not exactly divisible by 2. Why? They are in 2k plus 1 form. So, they are odd numbers. Odd numbers or odd integers. Okay. Any odd integer can be expressed in the form 2k, in the form 6q plus 1, 6q plus 3, 6q plus 5. So, this is what we need to show that. Okay, you can look at example 2. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. Okay, we need to show that if any positive integer is of the form 2q and that every positive odd integer is of the form 2q plus 1. So here 2q comma 2q plus 1. We will use Euclid's algorithm. Okay, what's Euclid's algorithm? A equal to bq plus r 0 less than or equal to r less than b. Here a is any positive integer. A is any positive integer. R is remainder. B is some divisor, that is 2. Integer. Okay. Why you are taking B is 2? The question is given 2q and 2q plus 1. So I have given B is 2. Now 0 less than or less than B equal to 2. What's the values of R? R will be 0, comma 1. Okay. If the all R value is 0 or 1, then what's the value of A? Therefore, A equal to 2q plus R, right? So here, okay, R is 0 or 1. 2q, comma 2q plus 1. Okay. For different values of R, I wrote value of A. Case 1 here. A equal to 2q. A is an even integer. A is an even integer. Case 2. Case 2, A is 2q plus 1. A is an odd integer. So positive integer can be even or odd. So why it is odd integer? We know that it is divisible by 2. Okay, it is divisible by 2. Okay, so this one, if it is not even, if not even, then obviously it's a odd. Okay, here case 1, a equal to 2q, so it is divisible by 2, so it is an even integer. It's a 2k plus 1, so it is not divisible by 2 and it is not even. If not even, then odd. It is a odd number. Okay, hence we show that 2q is even integer, 2q plus 1 is odd integer. So next example. So example 3. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. We will use Euclid's algorithm. Okay, again here a is any positive integer or is remainder, b equal to 4. We have taken b is equal to 4. In the question they are given like a 4q, so I have taken b is 4. If the b is 4, then 4. Then what's the value of r? 0, 1, 2, 3. Okay. Therefore, a equal to bq. bq means 4q plus r. r means 0. So instead of r, I will write all the numbers 0, 1, 2, 3. I wrote 0, 4q plus 1. This is for 0, this is plus 1, this is plus 2, this is for 3. See 4q plus 0, 4q plus 1, 4q plus 2, 4q plus 3. So again 4q and 4q plus 2, 4q and 4q plus 2 not 4q comma 4q plus 2 are divisible by 2. They are even integer. Even integers. So, okay, even integers. So what are the remaining terms? 4q plus 1, 4q plus 3. 4q plus 1, 4q plus 3. So 4q plus 1 you can write as 2 into 2q plus 1. This I can write as 2 into 2q 2q plus 1 and 1. Why I wrote like this? 2 2s are 4, 4q, 2 ones are 2 plus 1 3. This is something like 2k1 plus 1. It is like 2k2 plus 1. Okay, clearly 4q plus 1 comma 4q plus 3 are in the form of 2k plus 1. Okay, where k1, k2, k are some positive integers. So clearly 4q plus 1, 4q plus 3 are in the form of 2k plus 1. So they are not exactly divisible by 2. So they are odd numbers. So they are odd numbers or odd integers. So therefore any odd integer can be expressed in the form of 4q plus 1, 4q plus 3. Okay. Okay, it's example 3. So in the question they given 4q plus 1 and 4q plus 3 are odd integers. Okay, we need to show that. Okay, you can use Euclid's algorithm, a equal to bq plus r. So 0 less than or equal to r less than b. Okay, here b equal to 4. So why 4? I have taken 4. The question they given like a 4q, so I have taken b as 4. I have substituted 4 in place of b, so I got 0 less than or less than 4. It's mean that what's the values of or? 0, 1, 2, 3. So based on this, I got the values of a 4q plus 1, comma 4q plus 2, comma 4q plus 3. Okay. Note 4q, here 4q and 4q plus 2 are divisible by 2, so they are even integers. I have taken remaining terms 4q plus 1 and 4q plus 3. I wrote in the form of 2k plus 1. So clearly these are in the form of 2k plus 1, where k1, k2, k3 are some integers. Okay. So these two terms are in the form of 2k plus 1, so they are not exactly divisible by 2, so they are odd integers. Any odd integer can be expressed in the form of 4q plus 1. Any odd integer can be expressed in the form of 4q plus 1, comma 4q plus 3. Thank you for watching this video. Please don't forget to like, share, subscribe this channel.